Right, hello Year 11. Just going to make a little video going through some past paper exam questions on reacting masses. So in the lesson we learn how to do this technique I call down, across and up, where we divide by the MR to work out moles. We then use a ratio from the equation. We then work out moles of something else and then times by MR. So this is something that we've practiced in class, and I'm now going to show you how this looks in an exam, because we didn't actually do any exam style questions. Alright, so here's a question from, I think from around about 2019. Gold reacts with elements in group 7 of the periodic table. 0.175 grams of gold reacts with chlorine. So they're giving me a mass of gold and they're telling me it reacts with chlorine. Okay. The equation for the reaction is this. So this is crucial here. This equation is vitally important. And I'll tell you what I'm going to do with this in a second. So it says calculate the mass of chlorine needed to react with 0.175 grams of gold. So they want to work out this, the mass of chlorine needed, and they've given me 0.175 grams of gold. Now you can see here I haven't got much space. So in a minute, I'm going to write this equation nice and big underneath here. Also, as I'm reading through this, it says give my answer in milligrams. So that's going to be a little bit of a challenge at the end. And it gives me the relative atomic masses of chlorine and gold. All right, plan one, I want you to do this in the exam. Whatever the question is, I want you to write the equation out nice and big. All right, so that's my first thing. It's not taking me very long at all. What this tells me is that 2 of these react with 3 of these. It tells me that 2 moles of gold react with 3 moles of chlorine. I'm now going to put my 0.175 grams of gold under here, 0.175 grams. And again, I'm going to read the question, calculate the mass of chlorine needed. So they want this. They want it in milligrams. I'll do that at the end. I'm going to get some marks first. So I've got this, I'm going to go down from this mass, I'm going to go across here, and I'm going to go up. Notice how I haven't touched my calculator yet. All right, well, just touched it. Oh. So I'm going to go down by dividing by the MR of gold. Now, gold is actually just an atom, so I'm going to so I'm not using this big number, AU is 197. I'm going to divide that by 197. Remember the big numbers, I'm going to use these on the ratio arrow. 2 of these react with 3 of these. So I'm going to write that down here. 2 reacts with 3. Then to get back up, I'm coming back up to Cl2. Don't use the big number. The big number's been used on the ratio arrow. So Cl2, well, if Cl is 35.5, Cl2 is, I'll do this in my head, 71. Okay, that's 35.5 times 2 because it's Cl2. All right, so I think I've got a plan. I'm going to take 0.175, I'm going to divide it by 197. That will give me the moles of gold. I'm then going to use this ratio 2 to 3, which I'll show you in a minute, and that will give me moles of chlorine, and then I'm going to times by 71. This is my plan, and I'm now going to execute that plan. All right, so calculator on, 0.175, that's here, divided by 197. 0.000888. Now, on your calculator, that might be 8.88 times 10 to the minus 4. But I'm going to write it like this. 0.000888 moles of gold. I'm now going to do a 2 to 3 ratio. So this is your maths. I'm going to divide it by 2 and times it by 3. Okay, I'm going to divide it by 2 and then times it by 3. That'll make a bigger number. So watch, divided by 2 equals, times by 3 equals 0.001332. 0.001332. I'm not rounding. I'm keeping it not particularly rounded at the minute. So I'm not going to round this to like 0.001 or anything like that. I'll get the answer wrong. Now I'm going to times that by 71. Look, I haven't pressed clear on my calculator, so it's just times 71. And I've got 0.0946. 0.0946. And that will give you an answer in grams. So I'm going to write this now, 0.0946 grams of chlorine is needed. I've got myself 1 mark for dividing by 197, 1 mark for this, 1 mark for times 71, 1 mark for getting this correct. So there's 4 marks already. That's pretty good. All right, I've now got to convert to milligrams. Okay. 1 gram equals 1,000 milligrams. So if you've got something in grams, this tells me I need to times it by 1,000 to get it in milligrams. All right, 1 is 1,000, 2 is 2,000. So I times it by 1,000. So I'm going to go 0.0946 times 1,000, 94.6 milligrams. I need to put it on the line actually, so I'll put it on the line. 94.6 milligrams is there. Just going to check if it wants any significant figures, and it doesn't. So that's 5 out of 5. Let's just check the answers. I'll just go straight to there, 94.6. Notice that this would have got me 4 marks for just doing it in grams. The point I want to show you is, just by doing any of these steps, you're going to get marks. Dividing by the MR, 1 mark. Doing 3:2 ratio, 1 mark. Timesing by the MR of the other thing, 1 mark. Right, I'll tell you what gets no marks, leaving it blank. All right, so you need a strategy whereby you're not going to leave it blank. All right, so you can get as many marks as possible. That's Miss Clay walking in there, banging the doors. Outrageous. Right, let's do another one. So I'm going to attach these ones to document or put it on Teams or something so you can try these. But if you can't be bothered doing that, you can just have a little look at this, freeze the video, you can write out the question, I don't mind. All right, I'm going to just crack on though. So I've got another calculation, this is from 2020 I think. Magnesium reacts with iron chloride solution. Notice I've got an equation and I've been told a mass of magnesium and excess iron chloride. What that means is you've got so much iron chloride you don't need to worry about it. So don't worry when it says the word excess. I've got this much magnesium, I've got loads of iron chloride, and it wants to know the mass of iron produced. All right, so that's iron. It wants to know the mass of that produced, and it's given me 0.120 grams of this. Now I haven't got any space to work in, so I'm just going to write the equation out nice and big. I want you to realise there's a system, and I want you to use this system because it gets you marks. It might not get you 5 out of 5. It might get you 3 out of 5, but that's better than the person next to you, isn't it? So let's just stick with this system, 3MgCl2. What this tells me is 3 of these reacts with 2 of these to make 2 of these and 3 of these. That's what that tells me, the big numbers. All right, 0.120 grams. 0.120 grams of magnesium reacts with excess iron chloride, so you've got loads of this. Here are some relative atomic masses. They're going to be useful in a minute. Calculate the mass of iron produced. So there's iron. All right, in milligrams. Again, they like this, don't they? So you be aware of that in the exam, please. 1 gram equals 1,000 milligrams. Right, let's crack on. I go down, I go across, I go up. 3 of these makes 2 of these, so I'm putting that on here. You need to be comfortable with a 3:2 ratio. All right, I'm going to divide by the MR, I'm going to times by the MR. All right, magnesium. Magnesium weighs 24, so magnesium is 24. Please notice I didn't do 3 magnesiums because the 3 is taken care of on the ratio line. On the ratio arrow, sorry. So I'm dividing by 24 because that's just mg. I'm then going to do 3:2 ratio, and I'm going to times by, right, iron, Fe. Not 2 irons, just Fe, 56. All right. If there was a small 2 after this, yes, it would be 56 times 2. But a big 2 in front, we ignore the big numbers when we're calculating these MRs. Here's my plan. This looks like a really simple plan, doesn't it? So I'm now going to get my calculator. 0.12 divided by 24 equals 0.005, and I want you all please to write moles. I want you to show off to this examiner what you're going to do. All right. Now 3 to 2, I'm going to divide by this number and times by this number. So divide by 3 times by 2. Divide by 3 equals times by 2 equals 0.00333. 0.00333. That will do, or you could put a dot on top like you do in maths. That's moles. A little check of this. This ratio means if this was 3, this would be 2. So I'm just going to check that this number on the right is smaller than this number, 0.005, 0.003. Cool. It looks like I've done the ratio the right way. That's where I am on my calculator, 0.0033333. I'm going to times it by 56. 0.186, and that's recurring as well, and that's grams. All right, so I've nearly done, but I'm not going to miss this milligrams trick. I know I've got 4 marks out of 5 so far. 1, 2, 3, 4. 0.186 grams equals, now it was times by 1,000, because I wrote it up there, times by 100, oops, button stuck, times by 1000 is 186.6. Mr. Maidham's now in the room. They're on. You're teaching right now? Oh no. Right, I'm going to have to pause this and carry on later. So, 186.6, oops, milligrams. Just check that's right. Now, it didn't ask for significant figures, so it's gone. See, there's my 4 marks there, 0.1866 grams. So they've rounded that to 187 milligrams. 186.6, that's going to be fine because it didn't ask for sig figs. I'll pause this and carry on in a second. Right, I'm back. I've been kicked out into the corridor by Mr. Maidham. So what we've got here then, I'm actually just going to leave question 3 for a second because it's got an extra layer on it. So I'm going to move on to question 4. You know what, before I do that, I'm just going to look at question 1 and 2. And these, I've printed off some mark schemes for that question that we've just done. The one that was 186. So you hopefully are thinking, oh, that looks all right. I'm probably going to get 4, maybe 5 out of 5 on that. I'm going to show you the examiner's report. Students found this question tough, but it discriminated well, with higher retaining students being able to achieve 4 or 5 marks. 10% of students got 4 or 5 marks. That means 90% of students did not get 4 or 5 marks. But read this, 74% of students scored 0. All right? You are not going to score 0. You're going to get 3, you're going to get 4, you're going to get 5. So go into there realising you do a little bit of work on this, you're going to do well. Okay, let's look at the next question then. Question number 4. Another down, across and up. Okay, so I'm going to talk a bit less on this. Sulfur dioxide is an atmospheric pollutant. Alright, so I've got an equation. Looks quite easy to me. 1 to 1 to 1. 7 grams of calcium oxide reacts with an excess of sulfur dioxide. Calculate the mass of calcium sulfite produced. Well, that must be this, because that's calcium and that's sulfur dioxide. Alright, straight in. Equation. SO2, CaSO3, 7 grams of calcium oxide, excess of sulfur dioxide, that's, I've got plenty of that. Calculate the mass of calcium sulfite produced. So it's down, it's across, and it's up. Down, divide, up, times. This is a 1 to 1, so that's going to be fairly straightforward. That means a lot of students are going to get this correct in the exam. Right, divide by calcium oxide. So calcium oxide is a calcium and an oxygen. So that's 40 plus 16, that's 56. You've got a mark for working out 56. Calcium sulfite. That was Mr. Atkinson coming past, making a interesting noise. You alright with that? Calcium sulfite. That weighs 40, that weighs 32. And that weighs 16, 16, and 16, that weighs 48. So I'm going to get my calculator out to work out this MR. 40 plus 32 plus 48 equals 120. Alright, so there's my plan. Divide by 56 times by 120. There we go. 7 divided by 56 equals 0.125 moles. 1-to-1 ratio, so that means you're going to make 0.125 moles of this, times it by 120, times by 120, equals 15 grams. Doesn't want it in milligrams, 15 grams. That was an easy one. I hope it's harder than that in the exam, because loads of students will get that right. Let me just read the mark scheme for the examiner's report. Over a quarter of students got full marks and 80% got some credit. So use a 1-to-1 ratio and it's easy. All right, most students are going to score on it. So we hope for a harder question. All right, question 5 that I've printed off here. It's more of the same. Sulfur reacts, fluorine reacts with sulfur to produce sulfur hexafluoride. Let's just crack on. Right, notice I'm not even messing now. I just go straight in. I've got my plan. Calculate the mass of sulfur hexafluoride produced. That must be this. Sulfur hexafluoride produced. That's sulfur with fluorine, and there's 6 of them. So that's hexafluoride. Anyway, they want this, and I've got 0.950 grams of fluorine. 0.950 grams of fluorine. And we've got an excess of sulfur. So we've got plenty of sulfur. All right. Give your answer to 3 sig figs. All right. Notice on this last line they'll say, give your answer in milligrams, give your answer to 3 sig figs. So always check that, because that's your bonus mark. All right? That's your bonus mark, so read it carefully, please. All right, so I'm going to go down, across, and up. My ratio is 3-to-1. 3 of fluorines make 1 of this. Okay, I'm going to divide, I'm going to times. Okay, so I'm going to divide by, so it's F2. Look, I'm covering up the big number 3, F2. They're telling me here that F2 equals 38. That's to save me a bit of time in the exam, so I'm just going to divide by 38. SF6, they're telling me that weighs 146, so that's nice of them to let me know. 146. All right, there's my plan. 0.950 divided by 38 equals 0.025, and I'm going to write the word moles because I want you to write the word moles. 3-to-1. So what I'm going to do is I'm going to divide this number by 3. Divided by 3 equals 0.0083 recurring. I'm going to just write 3 like that. Now I'm going to, that's moles. That's moles of SF6. Now if I times by the MR times 146 equals, what does that say? Where's the decimal place? Can't see the decimal place on that. 1.216. 1.216 recurring grams. All right, so I know I've got 4 of the marks, and it wants it to 3 sig figs. So now it's 1.21666666666. So 3 significant figures, 1.22 grams. All right, doesn't want 3 decimal places, it wants 3 sig figs. Let's just have a little look. There we go, 1.216666666, 1.22 to 3 sig figs. All right, I haven't got the examiner's report for that, but I guarantee you that will be not many students got this right. I'm just going to look at this question before I go on to that one, question number 3. Explain why calcium fluoride has a high melting point. Okay, this is just for those students who are watching this who've learnt their structure and bonding stuff. So we've got ionic substances in this world, we've got simple molecular, and we've got metallic. Ionic substances are MC Bocal, simple molecular are WIF, metallic substance are Sab Pidel. Ionic are high melting point, these are low melting point, these are high melting point, this conducts electricity, this doesn't conduct electricity, this conducts electricity. Right, so this question says, why has calcium fluoride got a high melting point? So we're either looking at an ionic substance or a metallic substance. And what I can see here is calcium fluoride is made of a metal and a non-metal, and therefore must be ionic. Why has calcium fluoride got a high melting point? Because it has many strong electrostatic attractions between oppositely charged ions in a lattice, which take a lot of energy to break. If you're feeling confident, so that's going to get you 3 marks. If you're feeling confident, you can say that the calcium is forming the positive ions, or the 2 pluses, and the fluoride is forming the negative ions. But that's by the by. If you write MC Bocal requires a lot of energy to break, you're definitely scoring 3. It might even be worth 4 in the exam. Did you notice how easy that was? High melting point. That means it's either ionic or metallic. It's calcium fluoride, so it's not a metal because it's got a metal and a non-metal. Therefore, it's ionic. Right, back to question 3, and then we're done. This is a nice sort of 20-minute video. It'll be 25 minutes by the time I'm finished. So, question number 3. This is a reacting masses question like we've just done. However, there is something to do with solutions here. Now, in a solution, you have some water and a chemist has dissolved something in the water. So they might have put 1 gram of a substance in 1 decimeter cubed of liquid. So if you put 1 gram in 1 decimeter cubed, there is 1 gram per decimeter cubed. Because that means per, that's slash, 1 gram per decimeter cubed. If they put 2 grams in there, there would be 2 grams per decimeter cubed. All right? So this is the sort of question where we're talking about, this is called the concentration of the solution in grams per decimeter cubed. But please realise that this is read as grams per decimeter cubed. And it literally means, like this diagram shows, how many grams have been put in a decimeter cubed. Now, 1 decimeter cubed is 1,000 centimeters cubed. All right? So just bear that in mind in a minute when we come into this question. So you need to know this conversion. A decimeter cubed is 1,000 centimeters cubed. All right, let's have a look at the question. A student adds magnesium to hydrochloric acid until no more acid reacts and excess magnesium remains. This looks like making salts, actually, doesn't it? Magnesium plus hydrochloric acid makes magnesium chloride plus hydrogen. Okay, they're telling me that 0.72 grams of this, 0.72 grams is added to 100 centimeters cubed of hydrochloric acid. All right, I'm just going to write that down, 100 centimeters cubed, because that's going to be useful later. The hydrochloric acid is in excess, so we've got excess of this. The point I want you to realise is you've got 0.72 grams of this, so we can do down, across and up. It says calculate the concentration of the magnesium chloride solution produced in grams per decimeter cubed. How many grams there are per decimeter cubed. Now already this looks far more complicated than what we've done already, but let's just stick to our system. I want you to just think, I am not going to walk away from this with 0 marks. I want to get a few marks on the board. So let's just go with my system. Mg plus 2HCl makes MgCl2 plus H2. I'm going to write down 0.72 grams. They want me to work out the concentration of magnesium chloride. Well, okay, I'm just going to put a box there. I know they want concentration, but they want it in grams per decimeter cubed. Well, I can certainly work out grams quite easily. We'll do the per decimeter cube bit later. All right, so this is what you do in an exam. Look, even if you're panicking and it doesn't look like a normal one, we write the equation and we write down the mass of the thing that we've got, 0.72 grams. There it is. All right, I'll deal with the rest of it later. I'm just going to go and get some marks now. I'm going to go down, I'm going to go across, and I'm going to go up. I'm going to divide, I'm going to times. My ratio, there's one of these, there's one of these. So that's fairly straightforward, 1 to 1. Right, magnesium weighs 24. MgCl2 here weighs 95. So this bit's fairly straightforward, and already, even if you just stop after this, you've gained marks and you can leave it if you want to. So 0.72, divided by 24 equals 0.03, 0.03 moles. 1 to 1 ratio, 0.03 moles. Times 95, not times 85, 0.03 times 95 equals, so that's a 2.85 grams. All right, you've just got yourself 1, 2, 3 marks out of the available 6. You might have even got more, I think. Right, so I've worked out grams of magnesium chloride produced. They want the concentration of magnesium chloride produced in grams per decimeter cubed. So I know I've made 2.85 grams, that's this here. And I know that this is in 100 centimetres cubed of liquid. So I've got 2.85 grams in 100 centimetres cubed. And they want to know how many grams there would be in a decimetre cubed. Alright, so I've got 2.85 in 100. So how many grams would there be in a decimetre cubed? Have a little think of that for a sec. Okay. So, I know that 1 decimetre cubed is 1,000 centimetres cubed. So, I've got centimetres cubed and I want to turn it into decimetres cubed. There's a couple of ways of doing this, but if you look at this little thing here, to get from this side to this side, from centimetres cubed to decimetres cubed, I need to divide by 1,000. So 100 centimetres cubed, if I divide this by 1,000, is 0.1 decimetres cubed. Okay? So if I divide this side by 1,000 as well, 2.85 divided by 1,000 equals 0.00285. You know what? I've just made a bit of a boo-boo there. Just stop for a second. That's not the most sensible way of doing this. That is a way of doing it, but it's not the way I want to stick with. Sorry about that. I'm just looking at the time. Right. So I know if I've got this much in 100 centimetres cubed, if I want to turn it into a decimetre cubed is 1,000 centimetres cubed. So I want to know 2.85 in 100 centimetres cubed, how many grams in 1,000 centimetres cubed there must be. So that's times by 10. What I need to do here is times by 10. There are 28.5 grams in 1,000 decimetres cubed. I made a bit of a hash of that and I do apologise for that. So my answer is 28.5 grams per 1,000 centimetres cubed, which is a decimetre cubed. Sorry for messing that up a little bit at the end. I got a bit distracted by what was going on in the classroom. So I've got 2.85 grams in 100. They want to know how many grams are there in 1,000. So there are 28.5. Regardless of whether I lost you there at the end, you went down, across and up and you've scored probably 4 marks out of the 6 just for doing that bit of the calculation. And then just remember what that gram/decimetre cubed means. How many grams are there in 1,000 centimetres cubed? All right, I'm going to have to leave it there because I've got to go and teach. So again, apologies for that bit being a bit rushed, but I've got to go. All right, good luck on Friday. See you later.